A bacteria population is 4,000 at time t equals 0 and has a growth rate of 1,000 times 2 to the t after t hours. What is the population after 1 hour? So we know the starting population, and we want to know the population after 1 hour. This is effectively a net change problem. We want to figure out the net change, and then we can add it to the starting population to find the ending population. Now, when we're dealing with the net change for a population problem, a population growth rate problem, we have the integral from t sub 1 of t sub 2 of the rate of change, dn over dt dt, and that is the difference in the population at the ending time and the starting time. Now, we know the population at the starting time is going to end up being 4,000, and we want to figure out the ending population. And so what we're going to do is we're going to add n of t sub 1 to both sides, and that is going to give us the ending population is going to be the starting population plus that integral. All right, I've just taken the negative n of t sub 1 and moved it to the other side and rewritten it over here. So the ending population, the population after 1 hour, is going to be the starting population, which is 4,000, plus the integral from 0 to 1, that's our time interval of the growth rate, which is 1,000 times 2 to the t dt. And that's really all there is to it. So we've got 4,000 plus, now this is a continuous function, so we can use the fundamental theorem of calculus. So we need to integrate that. We can pull the 1,000 out, and then integrate 2 to the t dt. And we know from our table of antiderivatives, or our table of indefinite integrals, that's going to be 2 to the t over ln of 2. And then we need to evaluate that at 0 and 1. And life is a little bit easier if we pull that 1,000 out. I think that'll make life nicer. So then we just have to evaluate 2 to the t over ln of 2 at 0 and 1. So we've got 4,000 plus 1,000 times 2 to the first over ln of 2 minus 2 to the 0 over ln of 2. 2 to the first is 2, 2 to the 0 is 1, and 2 minus 1 is 1. So that's going to be 1 over ln of 2. And so this just becomes 4,000 plus 1,000 over ln of 2. And if you get an approximation of this with a calculator, you're going to see that this is approximately 5,443. So after an hour, that population has gone up from 4,000 to 5,443 approximately.